My name's Todd Henson. I'm the lead trainer of the National RV Training Academy, owner of Big Beard Batteries, and host of RV Unplugged. So we're real deep in the RV industry. And one of the things I do, one of the honors I have, is to train individuals to become RV technicians. So I'm going to do a brief overview for you of the electrical, just as I would if I were in class. First, I need to let you know that the RV has 3 different electrical systems. And some of them you're familiar with, some of them you aren't. We have 2 DC electrical systems and 1 what we call house system, or alternating current, 120 volts. The problem is some of these things are confusing. We don't know if it runs on 12 volts or 120 volts. We don't know that there are certain components that'll take 120 volts, step it down to 12 volts. Other components will take 12 volts and kick it up to 120 volts. And if you don't know that, then, if we use too much, cause problems or anything else, we're kind of out there alone in wherever we're staying. So first and foremost, there's 3 different electrical systems. The second thing is, from your home, you have anywhere from 4 to 10 times, 11 times less power from the RV than you do in your house. Now in your house, just to give you total wattage, you have 48,000 watts of potential that you can use. A 50 amp RV, 12,000 watts. So there's your 4 times less. And if you have a 30 amp RV, if you choose a 30 amp RV, then you're 11 times less, okay? Now, the reason why I always want to point that out and point that out first is you will find out in the RV, you'll trip breakers far more than you would in your house. And that's simply because we have less of a delivery system. So our takeaway with this is that you have anywhere between 4 and 11 times, you have a lot less power, right? So understanding that if you have less power, if you understood how much power you're actually consuming, right, then you know when you could turn things on, right? Have you noticed you could turn on any appliance, but you can't turn on every appliance, even if you're connected to shore power? And that's part of the problem. Now in the house, it almost seems like you can turn on anything, and if it doesn't turn on, you just take it to another outlet. Now it'll turn on. Very seldom do you ever pop a breaker inside the house. It is very common inside an RV. But let's jump over to the 12 volt system. Unlike your home, you also have 12 volt systems, 2 different 12 volt systems, as a matter of fact, and all RVs have that. The first, am I there already? Yeah, so that's what I was saying about trip breakers. Okay. I don't even use the PowerPoint. This is here for you guys to look at that instead of look at my face while I teach. I just kind of talk and make things up as I go. Yeah, so we have 2 DC systems and 1 alternating current system. When I say DC systems, I'm talking about you have 2 systems that run on batteries. Okay, 2 systems that run on batteries. Now I'll break those 2 systems up into 2 different categories. The first category, we'll call those the coach, right? You have a coach battery. This battery, the 12 volt system, typically in the RV, runs everything inside in the living space, also in the storage space. So your LED lights, your fans, if there's a control for it on the wall and you, the human, interact with it, that's 12 volts. More than likely in the RV space. We have new refrigerators now that run on 12 volts, so that is also a load. But then we have 2 large items that run on 12 volts, but cause a huge demand, and that's going to be, of course, your landing gear, should you have it, and your slide outs. Why is that important to know? Because you got 1 battery that's doing the work. And when we're talking low voltage, we're talking very little amounts of power that can happen. So you notice that with a lot of these units, towable units, if you're going to open up your slides, read the paperwork, it'll say plug in a shore power first. Okay? There's a little helper there called a converter. It takes that 120 volts, steps it down to 12 volts, and it assists the battery on heavy loads. Okay? Now, your coach battery is there, like I said, to run the 12 volts when you're not plugged into shore power. When you're plugged into shore power, what does the 12 volts, or what feeds the 12 volts for you? That converter that I just talked about. When you're plugged into shore power, the converter takes the 120 volts, steps it down to 12, and then feeds both the battery and takes care of most of the loads. And so your battery becomes the backup. It's there to help. Okay? Just like in your car, you start your car, the battery starts the car, but what runs everything while the car is on? Alternator. Alternator, but in a different box, different delivery system, converter. Same thing. Okay? So understand that we have those things. If you're looking for them in the RV, they come in two different varieties. Now, the picture I have here, this is what we call a combo unit. So where your breaker panel box and your fuse panel box is, they'll stuff the converter right up under it. So if you go over to your breaker panel box, and you'll see and you'll hear a fan, you'll feel the heat coming out. More than likely, that's where the converter is. Smaller units, combo unit. If you have a larger unit, Class A, a big fifth wheel, then what they'll do is they'll put this closer. They'll take this out, put it in a little case, just call it a standalone unit, and put it closer to the battery. Okay, and they always hide those things because they're electrical. They don't want you messing around with it. They hide it behind walls or stick it up on the ceiling or something like that. But again, our takeaway here is when you're plugged into shore power, both the converter and the battery work together to handle the loads inside the RV. The second DC system that we have, oh look, another picture that explains everything. I think I got it all. Yeah, fans, lights, control systems. Oh, furnace. Hey, one thing that we learned in Texas, we finally figured out what winter was a couple years ago. We had a Snowvid event, and we thought we as RVers were gonna be just fine because we can run on furnaces, and the furnace, runs on propane, because we had rolling blackouts. Well, didn't quite think that the delivery to get that hot air to the rest of the RV requires a 12-volt fan. And what we learned is that on a cold night, when you don't have shore power, you can't run your furnace for 12 hours, okay? You can't run your furnace for 12 hours because that's a large fan. As a matter of fact, outside of your landing gear and your slide outs, when you turn on the furnace inside an RV, that's the largest 12-volt demand that we have. And it's continuous until you turn it off, right? Because it has to deliver that much air. If you look at the fusing on this, it's got a 20-amp fuse. If you read the data plate on it, it'll say it'll draw anywhere from 8 to 14 amps per hour. 8 to 14 amps per hour. Well, wouldn't it be nice to know how much amperage we have inside the battery? A typical battery coming from an RV manufacturer is a 100 amp hour battery. What do we know about lead acid batteries? Can you discharge them 100%? No, about 50%. So how many hours can you run that fan? I can tell you, not all the way through the night. Not without help, right? We learned that the hard way. All right, so I'm just giving you some information on the coach. Okay, one other thing that the coach battery can do, not all RVs have this, but we can also supply the power to an inverter. Now the inverter is just the opposite of a converter. Now the converter charges the battery. An inverter will take the battery power and step it up to run the 120 volt items. It's relatively new in the RV. I mean, when I say relatively, in the last 10 or 15 years, but it's becoming more and more popular. Not all RVs have them. They do offer them, as options. But just understand that an inverter will take the battery power and run larger items. They all come in different sizes. Moving over to the starter battery. All RVs have a starter battery. All of them. Even the towables. Okay? Now, the starter battery runs a totally different system, right? On a towable, when you connect that 7-pin connector, you're connecting to the alternator of the starter battery. Right? This is how your running lights come on. This is how the brakes work, when you decide to brake while you're going down the highway. Okay? That all runs on the starter battery. Okay? And just like the same relationship that we have with our coach battery and that converter, the converter does the work whenever we're plugged into shore power, the alternator does the work whenever the engine is on. Now, we'll still say that it's coming from the starter battery, but that 7-pin or 4-pin connector, right, the number 3 pin that you have is actually feeding the 12 volts to your system, okay? So once you unplug that, if you have the towable or once you turn the key off on a motor coach, the starter battery is done. It's done its job. It's there waiting for you to start the engine once again, right? And then the alternator kicks in. Now, I said for slide outs, for those of you with a towable, plug into shore power, then run out your slides. If you have a motor coach and your motor coach has slides, I understand your motor coach has an alternator. Typically, when you read the paperwork, each manufacturer is a little bit different, but what do you think they ask you to do in order to get your slides out? Possibly keep the engine running, right? So now each manufacturer is a little bit different. They do that because when the engine is running, the alternator is there. The alternator helps out that battery, get that large item out. Okay? Now, another thing, and I know that this has nothing to do with electrical. Towables, in order to get your slide out, right, you have to be level first. So you have to level your RV before the slides go out. Some of you motor coach owners, you have to read the paperwork. They may say get the slides out first, then level. So if you're out there looking to shop around, don't just don't just listen to what I say, open it up. That manufacturer will tell you which way you need to go with that. All right, I know I'm speeding through this. That's simply because I want to get to questions. I have no clue what your questions are. I have some stuff that I want to go over. Why aren't you moving? Here, I'll just do that. Finally, we have house voltage. That's the 120 volts. Okay, house voltage, 120 volts. Just like you have in your house, that's typically what we call it. Well, what does it power? Well, it powers that converter, the one thing we can't see. When you plug into shore power, that converter is always on. All right, runs your air conditioner, residential style refrigerator if you have one, with a 120 volt compressor, your space heaters, your TV, and that's actually becoming a caveat now because we're coming out with 12 volt TVs, your water heater, electric heating element, should you have one, and then of course all your wall outlets. So it's just like in the house. The major difference here, you have very limited power. Very limited power, right? One thing I always have fun with is like when you buy a car, it's count how many cup holders you have. You can have 12 cup holders, but there's only seats for 4 people. So why do they give you 12 cup holders, right? The same thing with RVs, right? So the bigger the RV, the more outlets you have. More outlets doesn't mean more power. It just means more shared power, okay? One thing I do know is that the NFPA, because I teach on electrical, requires that we have 2 general circuits in the RV for our 120 volts. One of those is GFCI, one of those is just general. That's the minimum. How many do you think they give you, regardless of the size of the RV? Maybe 2, if you're lucky 3. Now count how many outlets you have. Okay, and if you've got 15 outlets on one circuit, there's a reason why in one room you've got one thing running, you'd run something else in another room and it trips the breaker. This is an odd occurrence for us because it typically doesn't happen that way in the house. The more wire we have, the heavier that RV is, the more expensive it is, right? We're trying to serve 2 goals when we make RVs. One is to make it as light as possible for you, but 2, keep the cost down. Well, in order to do that, you have to understand that we're sharing that power, okay? Not a big deal there. It's not that, they're being cheap or anything else. We're just trying to achieve, what we, the RV consumer, want. Part of that is we need to figure out our circuits, right? Well, when that trips, you need to figure out, okay, what other outlets did that just affect? Well, half the time it's half your RV. So then the whole goal of this, when we're talking about RV electricity again, is to understand that we have limited power and we have limited delivery systems. And so it's not about not using the power, it's using it wisely, okay? For those of you with a 30 amp RV, you have learned you can't necessarily run the air conditioner and the microwave at the same time. Now you can run either one of those, but you can't run both at the same time. It's on the same circuit, right? 30 amps, you're over that. So it's just learning that, those things. Okay, well, if I'm gonna cook, well, 1, I would always say learn how to cook, stop using a microwave. That's just me, right? But 2 is, for some of us, it's still like the air. I'll just go and turn the compressor off, leave the fan running, use the microwave, then when the microwave's done, go back and turn the air conditioner back on, okay? So again, my takeaway here is that you have limited power, but what I want to do is just to kind of give you a brief overview, but ask questions. What questions do you have? You come in here to ask questions, or you're looking for an RV and you're like, well, I don't know how this works. So I'm now going to open that up. Didn't race through it, but I'm going to open it up for questions because that usually takes the longest. Anyone have electrical questions? Yes.
So I have a 30-foot Winnebago Class A 30 amp, and my engine battery for the motorhome is shot. So I have to use the house batteries to pump it.
Right, so there's a little solenoid.
Exactly. And so obviously I've got some kind of drain on there. But last time I plugged in to 30 amp and the slide wouldn't come out, and I had to turn on just the ignition just turn it on to get the slide out? Is that because the
pathway?
engine battery is shot?
Okay, on a motor coach, the pathway for that slide out may be over with the starter battery. Remember I said that you had to keep that engine running? And if your battery is dead, yeah, you'd still have to open up that relay in order for the signal to go across. By the way, can you tell me what type of RV you have again?
It's a Winnebago Chalet 30-foot
Gotcha.
Class A.
Okay.
2008, yeah, so old, right? And we've been using small space heaters because we choose not to use the propane if possible.
Oh, I'm liking you. Go for it.
So, but I just saw another RV tech say, no, don't use that.
Why?
Well, he went into some technical detail, and I'm a liberal arts major, so I don't know.
Blibbity blah, 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 blah. No. Here's the thing. When most people, and you'll see it online or something like that, they'll take a picture like, oh, my space heater just almost burned down my coach. And what they'll do is they'll take a picture of a melted power strip. Okay? Now, power strip is the biggest oxymoron thing I've ever seen, right? They give you 16 different outlets to plug into, and you're still pulling off of one source. And you would think, well, maybe the size of the cable that they used was big enough to handle the 16 outlets. No. So here's the thing, okay? Remember, you have breakers, and breakers are not going to allow any more power to that outlet than what that breaker can allow. When you connect a power strip, you're actually now lowering the gauge cable that you have. Space heaters are absolutely safe if you plug them directly into the wall, okay? Because they're rated, they have different ratings. And typically, a good space heater is anywhere from 1,400 to 1,800 watts. Now, 1,800 watts, you better not have anything else on, because that's all that you can get out of that circuit. But a 1,500 watt, space heater in that wall, not a problem. Just take it directly to the wall.
Okay.
Yeah. And I'm not saying the tech is wrong, because we see what we see. And it's typically, yes, there's a lot of problems, but it's how we connected it, right? And that's all that it is. It's usually a melted power strip.
What if I had two? So I took the RV.
Okay. You did 2 space heaters.
So I took the RV with my sister. We took it. We're married, and we
Sure.
took it across country without him. And
Well, it
it
sounds
was-
like a wonderful marriage.
It was amazing. And so I plugged in 2 space heaters.
Gotcha.
Which now I'm hearing. I think I plugged them in on probably
On the same circuit.
line.
So-
And at 3 in the morning it blew, and I'm out there trying to figure out how to turn the breaker back.
So typically what I would do is come to class or whatnot. I'll tell you to buy what's called a GFCI tester, the little button you can press. Well, if you go ahead and press that, that should trip that circuit. Now what you do is walk around with that tester and you hook up all other outlets. And if it lights up, then that lets you know it's a different circuit. So you can still use 2, but you got to be on 2 different circuits, right? Then just tell your sister, hey, look, I know that couch is comfortable, but it looks like you're in the hallway, because that's where the space heater's going. Another thing weird about RVs, they'll give you, there for a while they've stopped it. They give you like 6 TVs, and not one of them was directly in front of the couch. If you just turn 45 degrees, there's the TV, right? But that's what we buy off of, right? How many of you bought a car and you're like, man, this has got so many cup holders?